one of the most loved and recognized animals in the world. A bird that cannot fly and once as large as humans. These birds may look like they were made for ice, but their story starts in a warm world filled with flying ancestors. So how did we get the penguin of today? It is not mere scientific curiosity, but a desire to understand the incredible paths life can take when faced with new challenges and new opportunities. Penguins exemplify nature's power to adapt, forsaking the sky, the ancestral home to all birds, for a life bound to the ocean. This was not a failure to fly, but a resounding success in learning to swim. To understand how this remarkable transition was achieved, the story must return far into the past, to a time long before ice covered this continent, when Antarctica was a world of forests and warmth. Our understanding begins by seeing the world as their ancestors saw it. A world without ice sheets, but with new oceans teeming with life after a global catastrophe. And that is where our journey takes us next. Their story will be followed from the very beginning, from the ashes of a lost world, to trace the epic evolutionary journey of the bird that learned to fly underwater. The story of penguins begins 66 million years ago. A world recovers from a great disaster. The dinosaurs have just vanished. The planet is warm and very different from today. In the southern oceans near present-day New Zealand, a new kind of bird begins its own adventure. These are not penguins as known today, they are pioneers. They are birds that still can fly, yet they spend more and more time in the water. They learn to hunt for fish in shallow seas, using their wings to propel themselves through the waves. This is the first step on a long road. Scientists trace how these early seabirds gradually lost the ability to fly. Giving up the air proves a worthy trade for mastering the ocean. Ancient beaches and prehistoric seas set the stage as the first ocean-dwelling birds claim the water as home. The journey spans vast time, from the warm, lush Paleocene to the icy landscapes of the present day. Clues left behind guide the story. Fossils are the storytellers of the deep past. These are bones of ancient creatures, preserved in rock for millions of years. Among them are the remains of giant penguins, some as tall as a human. The bones reveal their size, their shape, and how they lived. They show wings turning into stiff, powerful flippers, and feathers becoming short and dense to retain warmth in cold water. Each fossil is a chapter in this evolutionary tale. By looking back through time, the puzzle can be assembled. This is the journey that turned a flying bird into a flightless swimming marvel. The exploration of the past begins here. The journey back in time is complete. The air is thick, warm and humid. An unfamiliar sandy beach comes into view. The year is 62 million years ago, the Paleocene epoch. The age of dinosaurs has ended. A massive asteroid strike has cleared the way for a new world to take shape. Earth is a greenhouse. No polar ice caps, lush forests in Antarctica, warm oceans teeming with opportunity. This coastline lies in the region that will become New Zealand. Then low-lying islands beside a calm, inviting sea. The waters are much warmer than the icy seas of today. Warm seas favor new life. With mosasaurs gone, the oceans become safer for smaller hunters. In this world, the ancestors of penguins arise, still seabirds, searching for food and secure nesting sites. Many linger at the water's edge, diving from the air into shallow waves to catch small fish. They begin using wings to paddle, chasing prey underwater before surfacing. The first step toward a new kind of flight. The skies are crowded with competitors, but the sea is a vast open frontier, offering abundant food to diving birds. At this crossroads, some lineages commit to water. The choice reshapes bodies, lifestyles, and destiny forever. A million years later, evidence accumulates at sites that will yield a remarkable fossil discovery. In ancient New Zealand, a bird later named Wimmanu, Maori for water bird, leaves its bones in the sediment. Among the earliest penguin relatives, Wimmanu appears slender, with a longer, sharper beak than modern penguins. It propels itself with wings that are shorter and more robust than those of flyers, yet still jointed at the elbow and wrist like a gull. These traits suggest poor aerial ability, if any. The wings are improving for swimming, but losing power for sustained flight. To dive effectively, bones become heavier and more solid, an adaptation that ultimately makes true flight impossible. On land, such birds are slow and exposed. Unable to escape by air, they must nest in secluded, predator-sheltered places. The loss of flight confines these lineages to the southern hemisphere. Their descendants persist there to this day. In the Eocene epoch, as penguins committed their future to the sea, their bodies began a radical transformation. They grew larger, but more importantly, they grew sleeker. Evolution, acting as a master engineer, sculpted their forms into hydrodynamic torpedoes. This shape is a masterclass in efficiency, designed to minimize drag and slice through the water with the least possible resistance. Every curve was honed by the relentless pressure of the ocean, a clear signal that their destiny was no longer in the air, but deep beneath the waves. This streamlined physique was the foundational blueprint for the perfect swimming machine. To conquer the cold ocean, their feathers underwent a profound change. The long, delicate structures built for flight vanished. In their place grew a dense coat of short, stiff, and tightly overlapping plumage. These feathers, numbering up to 15 per square centimeter, function less like a bird's and more like chainmail armor. They interlock with microscopic hooks, forming a near-perfect waterproof barrier against the frigid water. To maintain this seal, penguins spend hours preening, meticulously distributing oil from a gland at the base of their tail, ensuring every feather is perfectly aligned and coated. But this coat's genius lies in what it holds, a crucial layer of air trapped against the skin. This is not just insulation, it's a personalized climate control system. The trapped air, warmed by the penguin's body heat, acts as a thermal shield, keeping the skin dry and warm even in sub-zero waters. It's a natural dry suit, far more effective than any we could design. Upon surfacing, a quick shake is all it takes to shed the water, the feathers instantly ready for the next plunge. On land, their posture seems a compromise. Legs and feet shifted dramatically rearward. In their flying ancestors, limbs sat directly beneath the body for balanced walking and landing. In penguins, they migrated far back along the torso. This creates their famous, almost comical waddle, a gait that is energetically costly. But this awkwardness on land is a direct trade-off for unparalleled grace in the water. Set so far to the rear, their webbed feet and short, stiff tail feathers combine to form a highly effective rudder. They can execute hairpin turns and subtle adjustments with incredible precision, essential for tracking and capturing swift, agile prey like krill and silverfish. The most dramatic reinvention was the wing. It transformed into a flipper, short, stiff, and flattened. The hollow, lightweight bones of their flying ancestors became dense and solid, reducing buoyancy and making it easier to dive. The joints of the wrist and elbow fused, losing their flexibility to create a rigid, powerful paddle, incapable of folding but perfectly suited for generating thrust in a medium 800 times denser than air. With these new flippers, penguins didn't stop flying. They simply changed their sky. The swimming stroke is a modified version of a bird's wing beat. It carves a figure 8 pattern through the water, generating lift on both the downstroke and the upstroke. But here, in the dense medium of the ocean, that lift translates directly into powerful forward thrust. They are, in essence, flying underwater, a technique that is both incredibly powerful and remarkably efficient. To power these underwater wings, the penguin's entire upper body was rebuilt. The keel, the massive breastbone that anchors flight muscles in birds, is retained and, in some species, even enlarged. This solid anchor supports the immense muscles needed for swimming. The pectoralis muscle, which powers the forceful downstroke, is enormous. But uniquely, the supracoracoideus muscle, which raises the wing, is also exceptionally strong. This allows the upstroke to be an active power-generating phase as well, doubling the propulsive output of every single flap. The land-bound waddle is a clever disguise. Beneath the feathers lies an aquatic athlete, a marvel of biological engineering tuned for endurance, precision, and explosive speed. Some species can reach bursts of over 35 kilometers per hour. When traveling long distances, they employ a technique called porpoising, leaping out of the water to breathe without slowing down. a beautiful display of their power and efficiency. But speed is only half the story. To hunt effectively, they must also master depth. As a penguin begins a dive, a suite of physiological changes kicks in. Their heart rate plummets, a phenomenon known as bradycardia, from over 100 beats per minute at the surface to as few as 20. Simultaneously, blood flow is restricted from non-essential organs and redirected to the brain, heart, and swimming muscles, conserving precious oxygen where it matters most for the hunt below. Their muscles act as internal scuba tanks. They are saturated with myoglobin, a protein that binds and stores oxygen directly in the tissue. This gives the swimming muscles a private reserve, allowing them to function for extended periods without needing fresh oxygen from the lungs. Before a deep descent, they also exhale, reducing the amount of air in their lungs. This might seem counterintuitive, but it limits buoyancy and, more critically, reduces the risk of gas compressing under pressure and causing decompression sickness, or the bends. These incredible adaptations combine to open up a vast vertical world. The deep, dark ocean becomes a rich hunting ground. While many species hunt in the upper 100 meters, the emperor penguin can dive for over 20 minutes, reaching astonishing depths of more than 500 meters, over 1,800 feet, where the pressure is immense and the light is all but gone. Down here, they are the masters, perfectly evolved swimmers in a realm far from the sky they once owned. After perfecting their bodies for a life in the sea, penguins were ready to conquer the southern hemisphere. Their conquest wasn't one of aggression, but of incredible endurance and opportunism. They became masters of the ocean's natural transport system, following powerful nutrient-rich currents that acted as highways of water. These vast circulating gyres, especially the immense Antarctic circumpolar current, carried them on epic journeys, delivering them to new shores and unforeseen opportunities. It was a planetary-scale dispersal, a testament to their newfound marine prowess. Riding these powerful currents, they established footholds across the globe. They washed ashore on the rugged coasts of South America, the sun-drenched beaches of southern Africa, and the isolated shores of Australia and New Zealand. In one of their most astonishing journeys, they even reached the remote Galapagos Islands, right on the equator. For a bird family that evolved in the cool climes of the south, this was an extraordinary feat, proving their remarkable adaptability. As penguins reached these new, far-flung islands and coastlines, the very currents that brought them there now served to isolate them. Colonies became separated by vast stretches of open ocean. In these isolated pockets, evolution went to work. Local climates, different food sources, and unique predators began to shape them in different ways. Over millions of years, these subtle but persistent pressures sculpted their bodies and behaviors, producing the remarkable diversity of penguins we see today, from tiny to towering, from ice dwellers to tropical survivors. In the distant past, this diversification produced titans. From about 50 to 25 million years ago, when Antarctica was still temperate, true penguin giants ruled the seas. The most formidable of these was Palaeeudyptes klekowskii. Standing as tall as an adult human and weighing over 115 kilograms, it was a heavyweight predator, the largest penguin known to have ever lived. These giants were not just anomalies. They were the dominant form of penguin for millions of years, thriving in the rich, warm oceans of the Eocene epoch. But their reign was not to last. The giant forms vanished with the rise of new, formidable competition. Around 25 million years ago, the oceans began to change. A new class of predators spread through the southern oceans, early seals and small, toothed whales. These marine mammals were intelligent, fast, and hunted in groups, competing directly with the giant penguins for the same prey. The penguins, while powerful, were outmaneuvered in the hunt for fish and squid. Gradually, the pressure on the giants grew too great. Their size, once an advantage, became a liability, requiring vast amounts of food that were now being intercepted by more efficient hunters. They were outcompeted and, over time, disappeared from the fossil record forever. The future of the penguin family belonged not to the largest, but to the smaller, more agile species who could adapt more quickly to this new, competitive marine environment. A pivotal environmental shift followed this biological one: the final dramatic cooling of Antarctica. the warm, forested continent of the giant penguins era was gone. As tectonic plates shifted and ocean currents rearranged, the planet's climate cooled dramatically. Antarctica was plunged into a permanent deep freeze. Warm beaches and forests gave way to colossal ice sheets, in some places kilometers thick, completely reshaping habitats and rewriting the rules of survival. Out of this frozen crucible, the emperor penguin emerged as the ultimate ice specialist. This remarkable bird didn't just endure the cold, it mastered it, becoming the only bird to breed through the brutal, unforgiving Antarctic winter. This strategy allows their chicks to fledge in the slightly more forgiving summer, but it demands an almost unbelievable level of endurance from the parents. The males undertake one of nature's most arduous vigils. They stand on the open ice for 2 months during the polar night, in unbroken darkness, each incubating a single precious egg on his feet. To protect it from the lethal cold of the ice, they balance it carefully, tucking it under a warm fold of feathered skin called a brood pouch. Throughout this entire period, they fast, surviving on their fat reserves through temperatures that can plummet below -60 degrees Celsius. Their greatest secret to surviving this ordeal is cooperation. To combat the lethal wind and cold, they form tight huddles, pressing together by the thousands to share warmth. But this is no static formation. The group continually and slowly shuffles, as birds on the frigid, exposed edge gradually work their way into the insulated center. It is a living, breathing wave of shared survival, allowing the group to endure what no single individual could ever withstand alone. But the story of penguins is not only one of ice and cold. Beyond the deep freeze of Antarctica, other penguins settled in temperate and even tropical zones. Here, the challenge wasn't surviving the cold, but escaping the heat. On the coasts of Africa, South America and Australia, conditions can be mild, but at times, searingly hot under the midday sun. Heat brought new and ingenious evolutionary solutions. To cope with high temperatures, many species, like the African penguin, have bare pink skin patches around their eyes. When they get too hot, they can pump more blood to these areas, which act like radiators to help shed excess warmth into the air. To escape the midday sun entirely, many temperate species nest in underground burrows or deep within coastal vegetation, creating their own shade. Life in these warmer, more crowded lands also meant new and ever-present dangers. On shore, a greater variety of predators, from foxes and snakes to birds of prey, stalk their nests and chicks. And offshore, the threat is just as real. Fast-moving sharks and powerful sea lions test the speed and agility that was first honed in the colder southern seas, forcing penguins to be constantly vigilant. Through millions of years of dispersal, diversification and adaptation, penguins became one of the most successful and widespread seabird families on Earth. From the frozen heart of Antarctica to the equatorial tropics, they have proven themselves to be resilient navigators and masters of survival, ready to face the ever-changing challenges of a dynamic planet. For millions of years, penguins evolved in a world largely without humans. In recent centuries, human contact arrives on their shores. Lacking innate fear, many colonies meet people at close range. The year is 1895. On sub-Antarctic islands, settlers harvest penguins for oil. Thousands are herded into pens and boiled to render fat, an efficient, brutal industry. Eggs are collected by the tens of thousands. Introduced predators, cats, dogs and rats, raid nests. With no defenses against these newcomers, long stable colonies collapse. Direct exploitation has mostly ended. New pressures rise. Industrial fisheries remove the same prey penguins need. In many regions, humans are now their primary food competitor. Scarcer prey forces longer foraging trips. Adults expend more energy and return with less. In many places, chicks starve in their nests. Pollution is a constant threat. Oil strips waterproofing and insulation, often proving fatal. Plastic entangles or is ingested, blocking stomachs and injuring birds. A pervasive challenge overlays them all: rapid planetary warming. Sea ice that should be solid and stable breaks up earlier in spring, reshaping breeding and feeding grounds. For emperor penguins, the threat is direct. If sea ice fractures before chicks gain waterproof plumage, broods are swept into frigid water and drown. The platform their strategy depends on is literally melting. A stark question remains: can these resilient specialists adapt fast enough to a human-driven pace of change? Across deep time, penguins embody adaptation, awkward on land, athletic in water, the arc of a lineage that continually finds a way. Today's threats are not ancient cycles, but human-induced pressures. Humanity is the novel competitor and disturbance on their stage. Effective responses are known. Actions can include establishing large marine protected areas, reducing plastic at source, improving spill prevention and response, and managing fisheries sustainably. Addressing climate change remains the greatest challenge. This bird carries a legacy of 66 million years of survival. Penguins have adapted repeatedly. Now outcomes hinge on human choices. The next chapter of their story will be written by policy and collective behavior. With timely action, their journey can continue, and future generations may still witness these masters of ice and ocean.